Okay, guys, so today, 1.4, literal equations and formulas. Before we start, we need to define what a literal equation is. So in your vocab page, let's put down literal equations. A literal equation is an equation that involves two or more variables. For example, 10x plus 5y equals 80. Okay, so before we've only been working with equations that have x only, or a only, or m only, something like that. Now our equations are going to have two variables. Okay, so more than one variable. I will show you how to solve them. So the first example, example 1, I give you the equation 10x plus 5y equals 80. X is the number of pizzas and y is the number of sandwiches. I want to know how many sandwiches can you buy if you buy 3 pizzas, and how many sandwiches you can buy if you buy 6 pizzas. All right, guys, so for these types of problems, notice that I have x and y on the same side of the equal sign, right? But I want to only solve for sandwiches, which is which variable? Y. So before you start plugging stuff in to solve, I want you to, in the equation, solve for y and get y by itself. The reason we do this is because I'm going to be plugging in 3 pizzas, and then I'm going to be plugging in 6 pizzas. So I want to isolate the y variable first, so that way when I start plugging in my pizzas, I just have to plug it in and simplify. Does that make sense? So we already have the equation solved for, and then when we plug stuff in, we just have to simplify. So underneath the problem, I'm going to rewrite the equation 10x plus 5y equals 80. And then I'm going to start solving. When we have 2 variables, or even more than 2 variables inside the equation, we still follow the same steps for solving. So I'm trying to get y by itself. So first I need to get rid of that positive 10x by subtracting 10x. That gives me 5y equals 80 minus 10x. And then I need to get y totally by itself, so I'm going to divide both sides by 5. Now, when you divide that right-hand side, you are dividing the entire thing, 80 minus 10x, by 5. Okay, so make sure you show the whole thing. Okay, we've actually done problems like this when we were doing distributive property. Remember, we pulled out the 1/5, and then we distributed it back in individually. I'm going to skip that step, and I'm just going to write it as 2 separate fractions. Is that okay with you guys? So that's going to be y equals 80 divided by 5 minus 10x divided by 5. Okay? And then you simplify. So y equals 80 divided by 5 is 16 minus 2x. Okay, that's the formula that we're going to use. Now, I want to solve for how many sandwiches, which is y, when we buy 3 pizzas and when we buy 6 pizzas. So what do you think we are going to do? Plug in 3 or 6 for which variable? X. I'm going to do 3 with you, and then I'm going to have you guys do 6. So x equals 3. That's going to be y equals 16 minus 2 times 3. So that's y equals 16 minus 6. So y equals 10 sandwiches.
How do you know? I got it right.
So what I want you guys to do now is now figure out what y equals when x equals 6. Go. Okay, so when x equals 6, we plug in 6, and you should have ended up with y equals 4 sandwiches. Yes? Okay. So what I want you guys to do is go to your book, do part A for me, but only do for when n equals -2. Otherwise, it's going to take too long. So we are on page 29, problem 1. First thing I want you to do is solve the equation 4 equals 2m minus 5n for m. So you're getting m by itself. I'll give you a hint. There might be a fraction in there. What are the values of m when n equals negative 2? So just find n equals negative 2 for me. You don't have to worry about 0 and 2. Okay? So just do that one for me. All right, so when you solve for m, you're getting m by itself, so the first thing you should have done was add 5n to both sides, right? Okay, so that would give you 4 plus 5n equals 2m, and then divide both sides by 2. 4 divided by 2 gives me 2, but 5 divided by 2 doesn't reduce, so you end up with 5 over 2n. Okay? If you wrote it as 2.5n, that's okay as well. I prefer 5 over 2, but 2.5 is the same thing, so it's okay. Yeah. So if you did it as 2.5n, it's actually the same thing. So when n equals negative 2, I already have the equation for m. I just plugged in negative 2. So that gave me m equals 2 minus 10 over 2, which is 2 minus 5, which is negative 3, right? So what if I give you a literal equation without any numbers at all? So ax minus bx equals c, and then the instructions are going to be solve for x. Okay, so ax minus bx equals c, and I want you to solve for x. All right, guys, on this problem, we're going to do our work on one side, and then we're going to write our steps on the other, because there are going to be problems as well where you have to, we call it justify your steps, where you have to write out the steps that you did, okay? So remember in lesson 1 when we were doing distributive property, and we had something that looked like this, and we undistributed the thing that they had in common? What do they have in common here? All right, so we're going to use the distributive property to pull that out. So that would be rewritten as x times a minus b equals c, correct? And that's the distributive property. So on the right, let's actually write our steps. So distributive property. We're just practicing this so that you guys get used to writing what you did. Okay, so I'm trying to solve for x. So right now I have x times the quantity of a minus b. So since this is x times the whole parentheses, what could we do to get x by itself? Divide. But we're dividing by the entire thing, a minus b, right? So then your step would be to divide by a minus b. So we're actually writing down our steps in words. Why does this work? Because a number divided by itself gives us what? 1. So a minus b divided by a minus b reduces, and we get x equals c over a minus b. Okay, guys, so do problem 2 for me. What equation do you get when you solve negative p equals r plus px for x? So you're trying to get x by itself. So what would you guys do first? Subtract r from both sides. So that gives me negative r minus t equals px, and then we need to get x by itself, so what did you do? Divide both sides by p. So that gives you x equals negative r minus t divided by p. Okay, so example 3. What is the radius of a circle with a circumference of 64 feet? For this problem, there is a formula that we can use, right? Okay, so let's add the word formula to our vocabulary first, and then we'll figure out what the formula is. Okay, so in your vocabulary page, add the word formula. It is an equation that states a relationship among quantities. And then I gave the example formula for area of a triangle. Area equals half times base times height. If you guys look in your book on page 31, they actually give you a whole bunch of commonly used formulas. Okay, so if you ever need a formula, check that page because it might have the one that you need. Okay, So looking on here, is there a formula for the circumference of a circle? Yeah, 2 pi r, right? So let's write that in our notes. So for example 3, we're going to use the formula circumference equals 2 pi r. So I am trying to solve for r. So before we plug anything in, let's get r by itself. If the formula is 2 times pi times r, how can I isolate r? Divide by 2 pi. So r equals circumference divided by 2 pi. They gave me the circumference, right? And I can estimate pi? Okay, so r equals 64 divided by 2 times 3.14. So that's going to give me 64 divided by 2 times 3.14 is 6.28, which comes out to approximately 10.2 feet. 10.2. So in your book, in example 3, when you solve for h, you should get h equals 2a over b, right? Okay, remember, I always want you to solve for the variable you are looking for, and then you can start plugging stuff in, okay? So you should get this far first, and then they want to know what's the height when the base is 8, so then you can plug everything in, and you should have got a height of 6, right?
Yes.
Okay. So make sure that you have that work. For example 4, guys, it's a word problem. I don't want to write a word problem in our notes, so we're just going to do the one in the book together, okay? So flip the page. Number 4. Okay, so number 4. Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico, and then back again. The whales travel a distance of about 500 miles each way. So what I want you guys to do is, will you underline that? 5,000, sorry. 5,000 miles each way. So that means from Alaska to Mexico, it's about 5,000 miles. And then to go back, it's another 5,000. 5,000. So 10,000 total. At an average rate of 91 miles per day. About how many days does it take the whale to migrate one way? Do we have a formula for distance?
Yes.
Flip the page and see if there's a formula for distance. It's dirt. Distance equals? Rate times time. So will you write that? Distance equals rate times time. So first write the formula we are going to use. Which variable are we solving for? T. So I need to get T by itself first. How would you solve for T?
Divided by R.
Divide R. So we get T equals, I'm trying to cover up the word, T equals distance over rate. Right? Okay. What's the distance?
5,000.
5,000. And what's the rate?
91.
Okay, so T equals 5,000 divided by 91. Plug it into the calculator and you end up getting T equals 54.99. Okay, that's like on the 54th day at 11:58, 11:59. So it's about how many days? 55. Okay, so about 55 days. If it was like 54.5, you could just say 54 and a half days. Or you could also round that up. Okay? But about 55 days for the whales to travel from Alaska to Mexico. That's like a month and a half, yeah. Okay, so those are your notes. On the left side of your page, you guys are going to do a couple problems for me. You are going to do, from the book, problem number 1. Problem number 4. Problem number 6. And number 7. Okay, so 1, 4, 6, and 7. You guys are working on that right now. For problem number 1, I only want you to do it for x equals -2 and x equals 4. Don't do 6. Okay, so 1, 4, 6, and 7. All right? So you're doing problems 1, 4, 6, and 7 from the book on the left side of your notebook. I will give you the answers before you guys leave so you can check your answers. Okay?